Okay, so today we're going to talk about circular motion and basic concepts about circular motion and the principles that you need to know about it. So the first thing that we need to know that the vector v, which stands for vector velocity, is constantly changing in position, but the magnitude of vector v always remains constant. So for example, if you have a person who is here, then here, then here, then here, and then here, this vector v, the vector velocity, is always changing. It's always changing position from here to here to here to here. But all of these vector velocities have the same magnitude. They have the same distance. They are all the same size. So that's why the magnitude of the vector stays the same, even though it's constantly changing. Another concept that should be known about circular motion is how to find the centripetal acceleration. Centripetal acceleration. Now, this means that the acceleration is always going towards the center or towards in the opposite direction of the radius. For example, if you have a vector going this way and the radius is here, the acceleration is going opposite of r. So this would be the acceleration, or the centripetal acceleration. Now, the centripetal acceleration equation is shown as a minus v squared over r in the direction of the radius, in the negative direction of the radius. That shows what we saw before, that if the radius is going this way, the acceleration is always going to be opposite of the radius. It is also important to know that the direction of acceleration always follows the change in the vector velocity. So it's shown as the change in the vector velocity over the change in time, or delta v over delta t. This just shows that if the vector is going this way, like so, the acceleration follows the change in the vectors. So it goes from here to here to here to here. Now, knowing all of these concepts, we can try to do an example. This example wants to know the velocity of a satellite around Earth. So the satellite is 8,000 kilometers from Earth, but we want to change these 8,000 kilometers into meters. So our new amount will be 8 times 10 to the 6th meters. This is the unit we're going to use in meters, not kilometers. Okay, now that we have our unit in meters, we can try to now start finding the velocity of the satellite that's orbiting around Earth. So we're going to use this equation. V squared equals magnitude of A times R. Now, we know that the magnitude of A is equal to 8 times 8 times 10⁶meters. Now, this here, 8 times 10 to the 6th meters, is the unit that we got before, which is the distance of the satellite from Earth. And this here is the given acceleration in meters per second that was given in the question. So 8 meters per second times 8 times 10 to the 6th meters. So this is the acceleration, and this is our r. Now that we have this equation, we can go ahead and start solving. So we're going to have v squared equals 64 times 10 to the 6th meters. Now we want to take the square root of both sides because we don't want v squared. We just want to find the velocity, not velocity squared. So when we take the square root of this and this, these cross out, this cancels with 2 of these 6's. So we're going to have v equals 8 times 10 to the 3rd m, or meters. Now that we have this, it's very simple to solve. Our v is going to equal 8,000 meters per second. And that is the velocity of the satellite that is going around Earth. Now that we were able to solve this example, we can solve one of these questions here. The question asks, what is the magnitude of the orbital velocity in meters per second of the Earth around the Sun? So we need to find the velocity of the Earth in meters per second when it goes around the Sun. So basically, we need to find this. This will give us the velocity. We need to multiply the acceleration times the radius. So, first, let's find the acceleration of the Earth orbiting around the Sun. So, in order to find this, we need to take the distance over time. So the distance that the Earth travels around the Sun is 9,420 million kilometers over 8,766 hours it takes to orbit around the Sun. So in order to, this will give us 30 kilometers per second. But we don't want kilometers, we want meters per second. So we need to convert this, and we get 30,000 meters per second. So 30,000 meters per second is our acceleration. It is how fast the Earth is going around the Sun. So now we know this much. And we're missing times r, or the radius. So let's find r now. R is given in the astronomical data table, and it says that it is 6.38 times 10 to the 6th power. So now we have everything we need. V squared equals 30,000 meters per second times 6.38 times 10 to the 6th power. Now we can go to solve this. So first let's multiply 30,000 times 6.38, which will give us a very big number. Now we take this number and multiply it by 10 to the 6th. But before we do that, we have to remember that this is what we're dealing with right now. So we need to take the square root of both sides because we don't want to find v squared. We just want to find v, the velocity. So if we take the square root of both of these, of this and of this whole equation, you're going to have v equals 191,400 times 10 to the third power. And then once this is solved, once you multiply these two, you're going to have that v equals 191 meters per second. And this is the velocity of the orbit of Earth around the sun.